Start our session with the microcontroller and interfacing with the microcontroller, we first understand the basics of an LED so that it becomes easy for us to understand the next stages. Here we are looking that we have an LED over here, which we say the front view of an LED. We have two terminals, one is the anode and the other is the cathode. Inside the LED we have two flags, one is the bigger flag and one is the smaller flag. The big flag is the cathode and the small flag is the anode. Normally people also say and explain the LED with the terminals, but if the terminals are cut and made equal, it is difficult for you to understand which is anode and which is cathode. So this is an easy way of understanding which is an anode and which is the cathode by just looking inside the LED. The bigger flag, again I repeat, is the cathode and the smaller flag is the anode. Now anode is the positive terminal of the LED and cathode is the negative terminal of the LED. LED is nothing but a light emitting diode having two terminals. Now this anode, which is the positive terminal, and this is the cathode, which is the negative terminal. Now we need to understand how an LED works. Let's see with the help of this simulation on Proteus. See, I have made four types of connections. The first type of connection is over here, where on the LED's anode I have connected a logic 1, that is plus 5 volts power, and on the cathode I have connected logic 1. So on both anode and cathode a logic 1 is connected. So now what will happen when on both the anode and cathode logic 1 is connected? The potential difference across the LED is 0 volts, as on both sides we are having 5 volts. So 5 minus 5 we have 0 volts. Since the potential difference is 0 volts, there is no flow of current across the LED. The diode is neither in the forward bias, neither in the reverse bias, and remains in the off state. The second case is over here, as we see that the LED the ground or logic 0 is connected to anode, and on the LED's cathode again ground is connected, that is logic 0. So on both anode and cathode we have logic 0 connected, due to which again the potential difference is 0 minus 0, that is 0 volt. There is no flow of current and the LED remains in the off state. The third case, as we see over here, that on the positive terminal, anode is a positive terminal and cathode is a negative terminal. On the positive terminal I have connected logic 0, that is ground, and on the negative terminal I have connected logic 1, that is plus 5 volts. Now what happens, the diode, since the opposite polarities are connected, hence the diode now goes into the reverse bias condition. The current flows in the reverse direction. The current flows in the reverse direction, and that current is called as leakage current. So now again, since the diode now the current flows, but since in the opposite direction, again the we say it is in the reverse bias condition and no photons are emitted, and again we see that the LED is off and no light gets emitted from the LED. The fourth case which is required, that on the positive terminal we connect logic 1 and on the negative terminal we connect logic 0. So now what will happen, 5 minus 0, the potential difference is 5 volts, hence there is a flow of current across the LED. Since there is a flow of current across the LED goes into the forward bias condition and light starts emitting, that is the photons start emitting from the LED, which appear to us as red light if you are using a red LED. And which other LED, if you use green LED, then it appears as a green light emitting from the diode. We just start the simulation and we see that there is a light being emitted from the LED. Here there is no flow of current. Here again we see there is no flow of current. Here there is a reverse bias current being flowing across the LED, and here there is a positive current being flowing across the LED. So hence we see that the current is plus 933 milliamperes. But this current is a large amount which will damage the LED. So what we do, we apply a current limiting resistor. We take a resistor over here, we break the circuit, and we apply a resistor over here. Since this is a simulation, we cannot see the LED being damaged, but in practically the LED gets damaged. So I change the value of the resistor to 220 ohms, and I now again play it. Now you can see that the current is plus 12.6 milliamperes. Now this is a nominal current which will not damage the LED, because if a current crosses a particular limit, it is going to damage the LED. That's all for this session. If you want like the video, kindly subscribe our channel, and so that you get the updates of the videos. Thank you very much.